everybody, it's Mrs. Williams, and today we're going to learn how to choose the best idea, which is the fifth step of the engineering design process. All right, let's get started. So first of all, you've spent a lot of time brainstorming and researching and developing ideas, and all of your team members have a different idea. So let's say that we have 4 different team members and each has a different idea that's represented here. You could simply vote. And often this can be used as a strategy. However, you might end up with 3 people liking idea 3 and 1 person liking idea 2, and you really need to come to consensus with the whole team when you are building a robot. So if you're not in agreement, this isn't going to work. And often this isn't how it looks. It usually looks more like this, because everybody has spent so much time invested in researching and sketching and developing their ideas that they really think their idea is good. And so they're attached to it. So most of the time, people vote for their own idea. So in order to avoid this situation, we use something called a decision matrix. Now, a decision matrix is a table that helps teams weigh the pros and cons of each design. You use criteria that we listed when we defined the problem or other criteria to help play the game as a way to rate each idea. And then you use that criteria to make the decision. So it really helps remove that emotional attachment to the design ideas, and you really choose the robot that's best for the game this season. All right, let's take a little closer look at this decision matrix. First of all, the ideas are listed in the left column. You can list them by numbers or by names, but you list them in the left column. And then you have the criteria along the top, including things such as cost or complexity. Now, we might not have those for robotics. Cost would relate to the number of parts you have. Do you not have enough parts to build your design that you have developed? Complexity would be how complex it is. That really relates to time. If it's too complex, you probably are not going to be able to have enough time to build it. So these are the criteria that we're rating our design ideas on. Okay, so our ratings are found in the middle of the table, and we use a 1 through 4 scoring scale, and we average everybody's score. So each member is going to rate the cost for idea 1, and then they're going to put it in this first box. So, and then we average that. So for example, if my team member rated the cost for idea 1 at a 4, and I gave it a 2, we're going to average that to end up with a 3 in this box. All right, next, let's take a look at the scale at the bottom. Not only do we have a 1 through 4 for best to worst, but if it's a question of yes or no, so does it fit in the size constraints? It might be a yes or a no. A yes gets a 2 and a 1 gets a no. But often it's not as simple as that with robotics, and we use the 1 through 4 scale. So it's important that you rate each criteria 1 at a time, that you start with this first criteria in the first column and you go through all of the ideas and you rate them on the first criteria, such as cost. This helps you compare the ideas to one another, so you can decide if one is more of a 2 and the other one's more of a 3. It helps you compare when you use the criteria and do all of the ideas on that criteria at one time. When you're done with all your ratings, you're going to add up all of the ratings and create a total in this last column. And you can see the one that has the highest total is the winner. So this idea 6 is the design that we will choose, but it's not based on the fact that everyone just likes that idea. It's based on the fact that it's the best for this game based on criteria. Okay, so let's talk about the process that we're going to go through in order to do this in our notebooks. The first thing that you need to do is everybody on the team will present their ideas. Each team member will go through and describe not only their design, but possibly any reasoning they used for choosing a subsystem, so that the other people can really understand where their ideas came from. Number 2, you're going to decide on criteria. So the team needs to come to consensus on what criteria are the most important to that team. These are just some sample criteria. You can choose other ones, or you can only choose a couple of these. It depends on what you think is important, and that is a team decision. You might think that how strong the chassis is important. And that means, is it going to be durable to attach the other parts, other subsystems on top? How fast does the chassis go? This may or may not be important to you. How high does the lift reach? How stable is it when it moves? Now, you might not know the answer to that unless you have experience with those types of lifts. So this might not be a good criteria for you if you don't know how to measure that. You might look at the number of objects or game field elements that the lift or the object manipulator can pick up at one time, or how many it can store. How easy it is to drive. How many functions does this robot have? Does it have so many functions that's going to be very difficult to drive and program all the buttons on the joystick? Which brings us to the ease of programming. We haven't been thinking about programming robots quite yet. You probably are going to do this after you start to build, but you want to think about, is it going to be easy to program this robot? How many motors? How many functions? Kind of goes with driving. Ease of building. This is that complexity criteria we were talking about just a bit earlier. The criteria, if it's too difficult to build, you might run out of time before it's finished. So you need to think about how much time you have to build, and will you be able to finish that difficult of a design, or is it easy and you'll have no problem finishing? You might look at the size, how big the robot is. If it is really close to the size constraints, like an 18 by 18 by 18 for VEX EDR, or a 11 by 19 by 15 high for VEX IQ, if it's really at the edge of those size constraints, you have a really it's very possible that you're going to go over in your size. So I wouldn't push it all the way to your 18 by 18 by 18 size constraint or your max size constraint. The smaller it is, the better you're going to pass inspection. So that's something to consider. And also integration of subsystems. How easy is it for these subsystems to connect together? Are there a lot of attachment points? So you want to think about, are they integrated well? Does it make sense for that object manipulator to be able to attach onto that lift in the way that it's shown? That is what integration of subsystems would be about. Now, for our Summer Academy, I have given you the criteria that you are going to decide on, but you can talk about this, but we will use the criteria that I've given you for Summer Academy. If you're building during the school year, your team needs to decide on this on your own. All right, number 3, we're going to draw a decision matrix. So you want to count up the number of ideas you have from your team members. If you only have 4 ideas, you don't need these last 2 rows. And then you're going to count up the number of criteria that you're going to put into this top row. And again, if you only have 3 criteria, you can get rid of a few of these columns. All right, so then you're going to draw your decision matrix in the notebook. And now it's time to list the design ideas. Now you can list them by number. Just make sure you know which design is number 1. And in the notebook this should be marked. You can also name them by the name of the designer or the type of subsystem it has. It's up to you, but you need to be able to identify each design by whatever you list in this column. Now we're going to write the criteria along the top. This summer, in Summer Academy, I have criteria for you, so you can use your assignment to fill those in. Otherwise, if you are a team during the school year, you will write in the criteria along the top. Now we're going to rate the first criteria. So we're going to look at all of the designs and we're going to put our ratings 1 through 4, going from worst to best on 1 through 4, and then we will move on to the second criteria, and so on, to the third, to the fourth. Finally, you're going to add up your ratings, and the highest score is the chosen idea. Now, when you're finished, a written explanation is needed to explain why this robot was chosen over the other ideas. It's really important to do this right away so that you remember why you did the ratings that you rated and why this decision was made. So a journal entry needs to follow your decision matrix that explains why this robot was chosen over the other ideas. Now, finally, If the team doesn't like the chosen idea, once in a while this happens, at least you've gone through the process and you understand the criteria that you're trying to build towards. Now, if you really don't like the idea, you can change it, but it needs to be 100% unanimous decision. You must all agree on the idea that you want to design instead of the one that was chosen by the decision matrix. This can be very difficult. This is why the decision matrix is there to begin with, is to take away that voting situation. However, there has been a few cases where people really want to build a certain lift and everybody wants to build it, and of course, that is your decision. But if you do this, you must provide reasoning in your notebook why you did not go with the decision matrix and why you decided on the other idea instead. So you still include the decision matrix in your notebook, but you just have reasoning of why you chose a different idea. All right, that's it for how to choose the best idea. I hope this helps you. Good luck, and don't get emotionally attached to your robots. Go with the criteria and let the decision matrix speak for you. All right, good luck.